In this module, we are going to talk about SSL VPN. We will cover the differences with IPsec VPNs, SSL VPN access modes, split tunneling, and client integrity. We'll also learn about SSL VPN portal, configuration, and monitoring. By the end of this module, you should be able to configure the different SSL VPN operating modes, set up SSL VPN portals, configure firewall policies and authentication rules for SSL VPN, and monitor SSL VPN connections. A virtual private network allows users to remotely and securely access private resources as if they were locally connected. It is generally used to send private information over a public network, so it is not only implemented for providing access to mobile users, but also for interconnecting geographically dispersed networks across the internet. The user data traveling inside a VPN tunnel is encrypted, so it cannot be intercepted by unauthorized users. It also uses different techniques to ensure that only authorized users can establish the VPN and access the private resources. There are different types of VPNs. The two most common ones are IPsec and SSL. In this module, we will be talking mainly about SSL VPN. IPsec VPN is covered in a different module. SSL VPN is commonly used to secure web transactions. Clients connect to a web portal and log in. It is essentially meant to connect a PC to a private network. This approach is simple in that users only need a regular web browser to connect. They are not usually required to install any kind of standalone client or go through a complex setup. They simply need to access an HTTPS website and log in. This makes SSL VPN an ideal solution for users who are either not technically skilled or connecting from public computers. IPsec can also be used to connect a PC to a private network. However, there are three important differences. Firstly, SSL VPN access is through a web portal, whereas IPsec is not. Secondly, IPsec can also be used to establish a VPN between two networks. Finally, IPsec is a standard protocol supported by most of the vendors, so a VPN can be established not only between two FortiGate devices, but also between different vendor devices. The FortiGate unit supports three different SSL VPN modes: web-only, tunnel, and port-forward. Let's start with web-only mode and the procedure to establish a web-only SSL VPN. The first step for web-only is to connect using HTTPS to the FortiGate device from any browser. The next step is to enter the credentials for authentication. After that, an SSL VPN portal is presented. As we will soon see in greater detail, the portal displays different widgets. One of the widgets contains links to all or some of the resources that can be accessed. Another widget allows users to type the URL or IP address of the server they want to reach. A web-only SSL VPN user uses these two widgets to access the internal network. The main advantage of web-only is that it is clientless. This means that the user is not required to pre-install any client VPN software. However, web-only mode has two main disadvantages. First, all interaction with the internal network must be done only from the browser. External network applications running on the user's PC cannot send data across the VPN. Second, a limited number of protocols are supported, such as HTTP, HTTPS, FTP, RDP, SMB CIFS, SSH, Telnet, VNC, and Ping. It is also important to know that in the case of web-only, The source IP address of the traffic originated by the user matches the primary IP address of the FortiGate internal interface. In other words, the internal servers will see all the SSL VPN connections coming from the FortiGate's IP address. Let's move on to tunnel mode. Although the initial 3 steps are the same as web only, there are some important differences with the remaining steps. First, users access the FortiGate via HTTPS, where they need to authenticate. They are presented with the SSL VPN portal again, but this time they use a widget called Tunnel Mode. By clicking on Connect, a tunnel is established between the PC and the FortiGate device. Inside the tunnel, IP traffic is encapsulated over HTTPS and sent to the other side. The FortiGate device receives the traffic and de-encapsulates the IP packets, forwarding them to the private network as if they originated from the inside. The main advantage of tunnel mode over web only is that once the VPN is established, any IP network application running on the client can send traffic across the tunnel. The main disadvantage is that this requires the installation of a VPN software client. If the client is not installed when the user accesses the SSL web portal, the Tunnel Mode widget offers the option to download and install it. Also, in Tunnel Mode, the FortiGate device assigns SSL VPN IP addresses to the users. They will be the source IP address of all the traffic generated by each user. Tunnel Mode can operate in 2 different ways, with and without split tunneling enabled. When split tunneling is disabled, all IP traffic generated by the client's PC, including internet traffic, is routed across the SSL tunnel. When split tunneling is enabled, only traffic destined for the private network is routed across the tunnel. So when split tunneling is disabled, the internet traffic goes to the FortiGate first, then goes out through the FortiGate device's ISP. This adds more latency and bandwidth usage. In most cases, split tunneling is enabled. However, some administrators disable split tunneling for security reasons, especially when it is required to monitor or restrict the internet access while the VPN is established. In those cases, internet traffic must cross the FortiGate device. Administrators can apply firewall policies and UTM profiles to control and monitor what users are doing on the internet while the VPN is up. We can establish a tunnel mode SSL VPN from a browser. The browser with the SSL VPN portal must remain open to keep the tunnel up. Alternatively, we can install and use FortiClient as a standalone SSL VPN client. Therefore, we do not need to use a browser. In either case, a virtual network adapter called FortiSSL is added to the user's PC when the SSL VPN client is installed. This virtual adapter will dynamically receive a virtual IP address from the FortiGate device each time a new VPN is established. All packets sent by the client use this virtual IP address as their source address. The third SSL VPN mode is called Port Forward. It uses a Java applet to extend the application supported by the web-only mode. The applet is downloaded from the SSL VPN portal and runs locally on the client's PC. It encrypts and forwards to the VPN all the data received on local ports on the user's computer. It is an intermediate solution between web-only and tunnel modes, as it allows the use of external IP applications without the requirement of installing a VPN client. However, it still has some limitations in the amount of network applications supported. Currently, 3 types of proxies or applications are supported. Port Forward for applications that support generic port forwarding, Citrix for connections to Citrix servers, RDP Native for Microsoft Windows native RDP client over Port Forward. SSL VPN sets up a portal to your network. In order to make sure that the SSL VPN is secure, the connection is encrypted and the user is prompted for a username and password. Additional checks can be done to increase your security. Client integrity can ensure to some extent that the connecting computer is secure by checking that specific security software is installed and running. This feature only supports Microsoft Windows clients as it accesses the Windows Security Center to check if an antivirus and/or firewall software is currently running. Alternatively, the feature can also be customized to check the status of other applications by using their globally unique identifier, or GUID. The GUID is a unique ID in the Windows Configuration Registry that identifies each Windows application. Client integrity can also check the current software and signature versions for the antivirus and firewall applications. The check is done when the VPN is establishing. If the required software is not running on the client's PC, the VPN connection attempt is rejected. Client integrity is configured per web portal and only by using CLI commands. We will see in a later slide what a web portal is and how to create them from the GUI. Let's move on to the SSL VPN configuration. There are basically 6 steps that we must go through. Regardless of the SSL VPN mode, be it web only, tunnel, or port forward, we must always do the first 4 steps. Configure the SSL VPN general settings, create user accounts and groups for the remote clients, create the web portals to define user access, create the firewall policy for SSL VPN authentication. Now for tunnel mode, there are 2 additional steps. Create the firewall policies from to the SSL VPN interface, add routing to ensure that packets destined to the clients are routed to the SSL VPN interface. Let's see in detail how to do these configuration steps. This is the SSL VPN general settings screen. As with any other HTTPS website, the SSL VPN portal presents a digital certificate when users are connecting. By default, the presented certificate is self-signed, which triggers the browser to show a certificate warning. If we want to get rid of the warning, we must first install a digital certificate signed by a well-known certification authority. 2. Select the install certificate from this drop-down list. 3. Check that the root CA certificate is already installed in all of the user's browsers. There are 3 levels of encryption: high, default, and low. Some older browsers do not support high encryption. In those cases, the VPN connection attempts will be rejected if this setting is set too high. By default, an inactive SSL VPN will be disconnected after 300 seconds. This timeout can be changed from the SSL VPN general settings screen. Also, by default, the port for the SSL VPN portal is 443, which means that users need to connect using HTTPS to the IP address of the FortiGate device and to port 443, which is also the standard port for the administration HTTPS protocol on the FortiGate. If we want to use port 443 for a different purpose, such as connecting to the FortiGate for admin purposes, we must change the SSL VPN port to a different one, such as 10443. Regarding the SSL VPN timeout, when an SSL VPN is disconnected, all associated sessions in the FortiGate session table are deleted. This prevents the reuse of authenticated sessions and policies by a different user after the initial one has disconnected the VPN. The second step is to create the accounts and user groups for the SSL VPN clients. We're not going to explain the procedure in detail, as there is another module completely dedicated to user authentication. All the FortiGate authentication methods, with the exception of Fortinet Single Sign-On, or FSSO, can be used for SSL VPN authentication. This includes local, LDAP, Radius, and TACAC Plus authentication. Two-factor authentication with or without FortiToken is also supported. The third step is the creation of the SSL VPN portal, which is what is displayed when the user logs in. Here, you can add, remove, or modify widgets that each user requires depending on the type of SSL VPN mode. As we will see later, when we create the SSL VPN authentication policy, we specify which user group will be using which VPN portal. More than one user group can share the same portal. We configure the SSL VPN portals under VPN SSL Portal. This setting enables users to use tunnel mode. This other setting can be used to enable or disable split tunneling. If using tunnel mode, we must select an IP pool which includes the range of IP addresses assigned to the tunnel mode users. We can configure the IP pools per portal or under the SSL VPN general settings. These three checkboxes enable users to use port forward mode. Also, if we disable this setting, the FortiGate will allow only one simultaneous SSL VPN connection per user. Here is a sample of an SSL VPN portal. As mentioned, it contains widgets. The bookmarks and connection tool widgets are used for web-only mode. Inside the tunnel mode widget, we can see the connect button that is used to start the tunnel and switch the SSL VPN from web-only to tunnel mode. Regardless of the SSL VPN mode, we need at least one firewall policy for SSL VPN authentication. This policy includes the user groups and which portal is going to be used for each group. When you configure the policy, the first thing is to select the type, which in our case is VPN. The incoming interface must be the interface facing the internet or where the SSL VPN connection attempts will be coming from. The local interface must be one of the FortiGate interfaces facing the internal network. Then you have the key parts of the policy: who is allowed to connect and what portal they will receive. It's almost identical to a regular authentication rule and works the same way. SSL VPN tunnel mode uses a virtual FortiGate interface called ssl.root. All the traffic originating from SSL VPN users will come from this interface, and all the traffic destined to the SSL VPN users must be routed to it. We need to add firewall policies to allow these packets access. To allow traffic from incoming sessions originated by the SSL VPN users, we must add a firewall policy with ssl.root as the incoming interface. To allow traffic from outgoing sessions destined to the SSL VPN users, we must add a firewall policy with ssl.root as the outgoing interface. The final step is related to routing. As tunnel mode uses a virtual interface, the FortiGate routing table must properly route the traffic destined to the SSL VPN users using the ssl.root interface. We usually do this with static routing. We add at least one static route for the VPN virtual IP addresses pointing to the SSL root interface. The FortiGate GUI includes an SSL VPN monitor table which shows all the SSL VPN users currently connected to the FortiGate device. It displays the usernames, IP addresses where the connections are coming from, and connection times. A subsession row below a user means that it is a tunnel mode user. At the right of those rows, we can see the SSL VPN IP address assigned. In this example, the user, Fortinet, is using tunnel mode and the user, John, is using web-only mode. We can see a summary of the 3 SSL VPN modes. Tunnel mode is the most versatile as it supports any IP application. However, it requires admin root privileges to install a VPN client. Web-only and port-forward modes are clientless, but they do not support all the IP applications. Web-only supports only access from the browser through the VPN portal. Port-forward supports some additional IP applications, but it requires users to change the application configurations to send the IP traffic to a Java applet that is acting as a local proxy. The final decision about which mode to use depends on many factors, such as technical knowledge of the users, type of network applications, and if admin access to the user's PC is possible or not. Now it's time for the lab. This lab will have you setting up SSL VPNs on a FortiGate device. In Exercise 1, you will configure a web-only access solution. In Exercise 2, you will set up a tunnel mode VPN.